Here is a short tutorial on critical path analysis. The way we are going to do things today is according to Corey Godfrey's CIT 380 Project Management class. The purpose of this activity is to find what set of tasks or path that has the least amount of slack time. Slack time is the extra time you have to work on the project. You will have zero slack time within the context of this class on the critical path. Thus, each task of the critical path must be completed on time. The first step is to align the tasks in order which they are shown on the task list table. The predecessor column indicates the activities that come before the task of that row. For example, task A has no predecessor, and it is first. Next, we can see that task B has a predecessor, A. That means that task A comes before task B. Some tasks will have multiple predecessors and some will have none. Draw arrows from box to box to show the relationships. Let's hurry and set the rest up. Now that we have that set up, we're going to add the duration to each of the tasks. The duration is, you guessed it, the time it takes to complete each task. You can find the duration in the task list table. For task A, the duration is 1. For task B, the duration is 3, and so on. So go ahead and now fill in the durations. With the durations finished, we can move on to the forward pass. The forward pass consists of early starts, early finish, and durations. The first task, A, is going to have an early start time of 0. In this class, all first tasks will begin with a start time of 0. We then find the early finish by adding the early start to the duration of that task, which we get 1. That means that the early start time is 0, early finish time is 1, and then all tasks which have A listed as a predecessor will start with early start time of 1. So B is 1, E is early start is 1, but then we get to G and we realize that it has 2 predecessors. In order for G to start, both task A and task E must be accomplished. Let's find out when E will be accomplished. We take early start of 1 plus the duration, which gives us an early finish of 2. We now can see that G can't start at the early finish of A, but must wait for E to finish. So G's early start time will be 2. Let's go ahead and finish the rest of the early starts and early finishes for each task. Now it is time to calculate the backward pass, the late finish, slack, and late start. This is done starting at the last task. We start at task J. We take the early finish of the last task, 25, and put it in as the late finish of that last task. The late finish is the latest you finish the task. The late start is the latest you can start the task. The slack can be calculated by taking the late start minus the early start, or the late finish minus the early finish. The result of that calculation is slack time, or the extra time you have to work on a task before its successor needs to start. When a task has more than one predecessor, make sure that its late start is the latest it can start, so that would be whatever predecessor task has the latest late finish time. Let me show you. So 25 is the late start time, and we take the late start minus the early start, which gives us 0 slack time. We can then see that the late start time will be 24, as there is no slack. So we must complete it in one time period. We don't have any extra time. We then take 24 and add it to the late finish for I. So it is 24. 24 minus 24 would equal our slack time of 0, which means we must get done in the 6 time periods. That would leave us at 18. Let's go ahead and finish off the rest of these, and I'll explain them as we finish. Now that we have all of those calculated, we can see in this breakoff that there is a late start time for task H of 15. As we input the late finish for D and F, both of the predecessors of H, they both are 15. That's where things change. Because F has an early finish time of 5, it can finish any time between 5 and 15. That means we have 10 extra days, or 10 slack periods of time, in which we can accomplish the task. We then take the late finish time minus the duration, which gives us the late start time. The latest we can start this task in order to still complete it for the rest of the tasks to not be delayed. We now want to find the critical path. The critical path for this class is the path of tasks that have 0 slack time. Brother Godfrey has set it up so that each of the tasks on the critical path will have 0 slack time. We can identify them by changing them to red. 0 slack time here, 0 slack time here, 0 slack time here, and we continue on. This is your critical path. It is the path in which we must accomplish all tasks on time in order to finish the project on time.